So when you register for the Zybooks, you will go to this website. This Zybook has different chapters, which I will start with chapters 1. If you go to chapter 1, I want to discuss chapter 1 today, but there are many different assignments in each chapter that I want you guys to work on. So chapter 1 talks about computer program basics. When you want to write a program, the most programs, they have 3 different parts. One of those parts is input, the other part is processing and output. Input is what goes to your program, which is what your program receives. So we can say a program gets data from a file, keyboard, touching screen, network, or someplace else. The program will perform some computations on that data, like adding two's value, like x plus y. The result of the running of your program will go to the output. We say a program puts the output, the data somewhere, like a file, screen, or network. When you want to write a program, you will create variables. The variables are something that you can store data inside. We say that programs use variables to refer to data like X, Y, and Z. In this example here, we have a computer program. The input goes in the X. The next input goes in the Y. We say Z equal to X plus Y. X is 2. From the keyword, the user puts 2. The user puts 5. 5 plus 2 is 7. Goes inside Z, and then you display the Z on the output. This is a very simple program that you have input, processing, and the output. So we say a program, most of the programs, they have these parts. It means they take some input, they do some processing, and then they have an output. Zybook has some participation activities. I want you guys to finish them. You will read the questions, you will try, you put an answer, and then you see. If you click show answer, it should show your answer. But I want you guys to follow all of these instructions and finish. We say a program is like a receipt. Like when you want to make food or you want to cook cookies. So you need to follow some steps to create that. Like if you want to bake chocolate chip cookies, you mix 1 stick of butter and 1 cup of sugar. You add egg and mix it until it's combined. If you follow these steps, you can bake chocolate chip cookies. When you want to create programs, you will follow some steps to create the program. There's a first programming activity in Zybook that you can see here how it works. If you just click run program, you can see what happens. In this class, I want you guys to finish all of these participation activities. In this example here, we put the 5 and the M. It says put M, 5 goes to the output. M equal to M times 2, it becomes 10. 10 goes to the output. M equal to M times M, put M. So I want you guys to finish all of these participation activities. We have something we call a computational thinking. When you want to solve the problems, you need to come out with a way to solve those problems. So we say a sequence of instructions that solves a problem is what we call it an algorithm. Algorithm means when you put some steps right after each other to solve a problem. There's another participant activity here that I want you guys to finish. If you go to section 1.2, there's a first program, which is a simple C++ program. We say a program starts in main, executing the statements within the main braces. Every C++ program has a main function. Each statement appears alone on a line, ends with semicolon. Semicolon indicates end of a statement. Like when you write a sentence in English, you put dot, which indicates the end of a sentence. We have an integer variable data type. It means that variable is a whole number. Like if you want to create a variable that can store 20, you could make it integer, int. The cout statement is used to display something on the output. So we say the cout statements output various values. We have return 0, which is the end of your program. Whenever your computer gets to return 0, that indicates that is end of your program. This 0 is telling the operating system that the program ended without any errors. So when you want to write a C++ program, you start your program with some code like this. You say hashtag include, for example, iOS string using namespace std. For now, whenever you write a C++ program, I want you guys to put these 2 lines of code on top. So if you put 2, I will explain what are these later. But in this example here, we have a simple C++ program that it says hashtag include iOS string. This iOS string is a library, which we call an input output string. It's used for reading and writing. It's used for working with computer. We have many libraries that I will discuss them later. Using namespace std means I want to use a namespace which is std. This is your main function. Every C++ program has a main function. int means integer. The return type for this function is integer. This open and close parentheses, it means that's a function. You open a brace, you close a brace. This is what we call a block of code. From opening brace to closing brace is a block of code. When I say int wage, I'm defining a variable wage. Wage equal to 20, I put 20 in my variable. Cout salary is cout wage times 40 times 52, cout end L. Zybook has like a built-in compiler that you can run your code. When you run it, you click on this, and then you keep clicking. You can see the output is displayed here. This is what you see on your computer, which is salary is 41,600. This wage is an integer variable. It means it can hold a whole number. We put value 20 inside wage. When you put equal, we call this assignment. Assignments, it means I want to put whatever I have on the right-hand side to the left-hand side. It means wage becomes a 20. When you display wage times 40 times 52, the value of the wage will get multiplied by 40 by 52, and then it will get displayed. I want you guys to finish these activities. There is another activity here, 1.2.2, and there are some built-in activities here that I want you guys to complete. This is an example of a basic input. So if you want to get something from the user, you can use CIN, which is CN. It helps you get something from the keyboard. We say programs commonly get input values. They perform some processing on that input and put output values to screen. The input comes from the keyboard. The output can go to the printer. It can go to the screen, to the screen. So we have different inputs and we have different outputs. If you want to get something from the input from the keyboard and put it in variable x, you can say cn, for example, double right arrow x. In this example here, we have a variable wage, which is integer. It means the whole number. I say cn double right arrow wage. I'm getting a number from the keyboard. I'm putting in this variable wage. I say cout salary is cout wage times 40 times 52, cout end L. If the user puts 20 here, wage becomes 20. 20 times 40 times 52 will get calculated, and it will display salary is 41,600. This program is a very simple program that shows how you can have both cin and cout statements. So the cin wages statement gets an input from the keyboard and puts the value inside this wage. With the cout, you can calculate what is the salary, and then you can display it. I want you guys to finish these participation activities. There is a basic output program here that shows how you can use the cout statement. So in this example here, we have a simple program that has 3 different cout statements. I say cout, keep calm, and carry on. If you look at the result, it displays keep, calm, and carry on the same line. because the cout statement will display something. Semicolon will stop that statement. This will display something else. In this example here, you see we have the same code, but we have end L. So this other code will display cout, keep calm. It goes to the new line and goes to the new line, carry on, and it goes to the new line. It displays keep calm and carry on separate lines. With the end L, you can send the cursor to the next line. We call it end line. That's L, it's not one. It's end L. You can also put this end L in the same line, in the same cout statement. In this example here, we have a program. This program is displaying, this is the first paragraph, goes to the new line. The cursor has been moved to the next line, goes to the new line, goes to the new line. This is the second paragraph. So this is the output. You can see that the end L sends the cursor to the next line. If you want to display a variable's value, you can use the cout statement. If you say cout double left arrow X, it will display X. In this example here, we have this variable wage, which is integer. When I say wage equal to 20, I'm putting 20 inside this variable wage. I say cout wage is cout wage and L. It will display wage is 20, and then it goes to the new line. It displays goodbye dot, and it goes to the new line. This is a very simple C++ program. I want you guys to finish these activities. You could output multiple items with one statement. In this example, we have a function here, which is the main function. I'm displaying the wage, and then I'm displaying goodbye. I'm displaying the wage is, which is a double quotation is used for strings. It means wage is a string, which string is an array of characters. I'm displaying this string and I'm displaying this variable in the same line. I want you guys to finish these activities. When you write a program, it's a good practice to write comments. So we have different ways of writing comments. Sometimes you have a single line comment, sometimes you have multi-line. Single line comments, they start with // Multi-line comments, they start with /*. They end with */. So in this example here, you can see that we have a comment. The comments, they make your code easier to read, easier to understand. It's a very good practice to add comments. So in this example, you see the programmer is putting some comments here, which he's putting his name and then the date and then description of what is this program about. So this is your main function. You have two different variables. The single line comment here is //. You can see there are two single line comments here for each one of these lines. It's a very good practice. The comments, they don't get compiled. They are not part of your program. They're just something there for the user to read. They are not a statement. So it's also a good practice to put white space in your program. We say white space refers to blank spaces like space or tabs between items. You could use black lines to separate distinct statements. You can end these lines with the same amount. You can align items to reduce a visual clutter. In this example here, you can see how we can make a good use of white space. So there's a white space before these two lines, first two lines, and your main function. The white space is increasing the readability of your code. There are single line comments on these lines. This is a good way of using white space and comments. You can see the comments are describing what these parts of the code or about. This is an example of a bad use of white space. You can see that everything is there together, which is not a good way of writing code. I want you guys to finish these activities. When you write a program, sometimes you have errors, sometimes you have warnings. We have different kinds of errors. So sometimes we have syntax errors. Like people, they make mistakes. Programmers, they're people, they make mistakes. Lots of mistakes. So one of the mistakes that you do when you write a program is a syntax error, which syntax error, it means when the programmer has violated the programming language's rules. If you don't respect the syntax of C++, then you will have syntax error. So in this example here, you see the program is dropping an error. Expected semicolon after express and see out traffic today. You have a simple program here that you have a main function. Since there's a missing semicolon here, the program is complaining, it's dropping an error. So this is an example of a syntax error when you don't respect the syntax. Sometimes you have some unclear error messages. In this example, the compiler error message is not exactly telling you what's going on. Like you have this function here that says expected semicolon after expression. But if you look here, there's a double if error missing, which the compiler is not exactly telling you what is the problem here. It's just complaining without specifying how to fix it. Sometimes the compilers, they drop errors that they don't make sense. So you have to make sure that you know what's happening there. I want you guys to finish these activities. When you want to fix the problems in your program, you can always start with fixing the first error. When you run your program, you will have a bunch of errors. First, fix the first one, ignore the rest of it. Look at the reported line of the first errors. If error found, fix it. You keep looking for the problems in your code. You fix them one by one. Every time you fix one error, you compile it again and you try it again. And then you keep doing that until everything is fine. There's an example here in your Zybook I want you guys to finish. I want you guys to finish these activities. So sometimes you have something that we call it a logic error. Logic error is different than syntax error. Logic error, it means when you don't when you make a mistake in logic of a program. So in this example here, you have a program that you have num beans, num jars, and total bins. Num beans is 500, num jars is 3. You're displaying num beans and num jars, and then rather than using multiplication, you're adding them together. And then you display the total. So the problem here is that you made a mistake. Rather than using multiplication, you added those two together, which we call this a logic error. The logic error can result in having programs that they run, but the output and the produce of the output of the program is wrong because there's a logic error in your program. This word box, it comes from many years ago, 1947, which engineers discovered their program on a Harvard University Mark II computer was not working because a moth was stuck on one of the relays. Many years ago, 1947, they found this. The program was not working. So this word box comes from there, which they even took a picture of it and they kept it until today. When you want to write a program, it's a good practice to write some code, compile it, make sure it works, then write some other code, add to it, compile it, make it sure it works. So compile and run after writing just few statements. Writing many lines of code without compiling and running is a bad practice. So sometimes the new programmers, they write lots of code, they try to run it, it doesn't work. Don't do that. Write some code, try it, fix it, and then run it again. A compiler will sometimes report a warning. Warning is not an error, it's just a warning. So it doesn't stop the compiler from creating an executable program, but it indicates a possible logic error. For example, some compilers will report a warning like warning divided by 0 is not defined. Like if you try to divide num items by 0, it will drop an runtime error, which is not a warning. This, if you try to divide by 0, you will get an error, which is a runtime error. So if you get the warning, you can always ignore them. If you get errors, then you need to fix them. So the computers and programs in general, it's good to have knowledge of computers. Like when you have a car, if you know how to fix your car, that's a good thing. It's good to know different parts of your car, how they work. The computers are built out of switches, which the switches they go to many years ago when they created the gates that you can turn them on and off. Like when you want to turn a light on and off, you click a switch. In your computer, everything is stored from zeros and ones, which we call it binary digits. So zero is zero voltage, 0 voltage, which is 0, and positive voltage, which we call it 1. Sometimes it's 0 and 5 volt or 0 and 15 volt. So the computer uses this standard to store information, which is the combinations of zeros and ones. This is a picture from early computer made from thousands of switches, which is in your computer, which was one of the early computers that were created. So the evolution of electronic and computers resulted in the computers that you guys have these days. First electronic computers in 1930s and 1940s, they were consisted of about 10,000 electronic switches and occupying entire rooms. Like this computer here was very big. The early computers were very big. It means whole building was one computer, which they had many, many different switches. And that is why they were large. And the technology advanced. And these days you can see that the computers, they became smaller. We have the processors and memory. The processor is the heart of your computer. Every program that you run, the processor will grab the instructions. It will put them together. It will compile your program, and then you can run. Everything in your computer happens by processor, which the process like a heart to a computer. It says to support different calculations, circuit processor were created to process or execute a list of desired calculations, which each calculation called an instruction. Instruction means when you write line of code. Whenever you write a line of code and another line of code and another line of code, when you run it, the processor grabs those lines of code one by one. It creates a program, and then you can run it. So these are like some pictures from switches. It says a switch is strong, so did computers. You can see the early switches, they were very large. If you look at this CPU on the right side, it contains millions of switches. So this is the difference in time. Like if you look at the early switches, they're so big. Now these days, you have a CPU, which it has millions of those switches inside it. Instructions are stored in memory. We say a memory is a circuit that can store either zeros and ones in series in different locations. Everything in your computer is stored as a series of zeros and ones, which we call that memory. So I want you guys to study this. This part talks about instructions and low-level instructions. You can study these and you can finish them. This part of your Zybook talks about Difference between high-level language and low-level languages. Which high-level languages are languages that are near to human language, like C++, Java, Swift. Low-level languages are languages that are not near to human languages, like assembly. C++ is actually a high-level language. So writing code in high-level languages is easy. Writing code in low-level languages is not easy, like assembly. Machine instruction, machine language is the language that the computer understands. The computer only understands combinations of zeros and ones. The computer doesn't understand anything else. Any code that you write, it has to be translated to a language that the computer understands, which we call that assembly language or machine language. It says in 1940s, computers originally wrote each instruction using zeros and ones. So you can see the early computers you were able to write code like this, like putting 0, 0, 1, 1, 1, 0, 0, 0, 0. So these days, when you want to write a program, you need to use a language, which it can be most of the time it's a high-level language. In 1960s and 1970s, programmers created high-level languages. It means these languages that you use these days are created by programmers. Some programmers sat down and created C++. Some programmers, they created Swift. Some programmers, they created Java. So these high-level languages are created and they're given to you to use, which is a tool that helps you write and create other programs. If you want to, for example, translate f equal to 9 divided by 5 times a C plus 32, you can write a program that does that. You can use any language like Fortran or Algol or other languages. I want you guys to study these and finish this activity. This section of your Zybook talks about what your computer has, which your computer has input and output devices like screen. It has a storage it can be a SSD, solid state drive. Your computer has a RAM, which is a random access memory. It has a processor that takes care of processing your instructions. It has a clock. So the clock is determined by the speed. Like the processors have clocks that tick at rates like 1 megahertz, which is 1 million ticks. The faster the clock speed of your processor, the computer will be able to run your programs faster. Computers typically run multiple programs simultaneously. When you write a program and you run it, it gets compiled. So inside the computer, you have all of these parts, like input, like keyboard, or mouse, or joystick. Your computer has an output, like a screen, or a speaker, or a projector. So the SSD is like a memory that your computer uses, like a flash memory, to store files and other data, like movies or songs. The RAM is a memory that when you turn off your computer, it gets erased. It's temporary holds data read from storage. So it's kind of temporary memory that it can get erased. So I want you guys to study this section. This activity shows how your computer works. Like when you have a program and then you run it, it says the computer solid state drive stores terabytes of data. This is your solid state drive. It has some programs. It has the operating system like program A, program B, and document 1 and document 2. The computer's memory can store gigabytes of data. So in the memory, you have data stored. Your processor has a cache with a fast memory inside the CPU. The speed of the processor is determined by clock, which is usually in gigahertz. So program gets loaded from the solid drive into the memory. Then processor runs the program A. This shows how the computer deals with programs, which grabs them and then runs them. It's good to study this. We have a law, which we call it Moore's law. So it says after computers were invented and occupied entire rooms, engineers created smaller switches, which are called transistors. These transistors, they were integrated into a single chip called integrated circuit or IC. So the IC contains transistors. IC is kind of their circuits that they have a logic built inside them. So the technology changed. Engineering continues to make transistors smaller, leading to Moore's law. So the Moore law indicates that the doubling of the ICU capacity roughly every 18 months, which continued for several decades. I mean, this Moore's law is saying that every 18 months, the capacity of ICU, they almost get doubled. This law applied for a while. So the technology advanced. When the technology advanced, this law may not apply exactly in 18 months. So these days, the computers, they have been very fast and they are able to run programs very quick. I want you guys to study this Zybook chapter. Section 1.7 talks about the language history. History of languages, which in 1978, Brian Kernkwang and Dennis Ritchie at AT&T Bell, they published a book describing a new high-level language, which is named C. You can see it comes back to 1978, where C was created and then published. So we have some other languages like C++, or Python, or C++, so Java, or C#. You can see they have different levels of popularity. Like Python is very popular. C and C++ are popular. We have some languages like assembly language is not popular. So different languages are built for different purposes. They are used to create different kinds of applications. We can say that C# is for Microsoft Windows programming. If you want to create a Windows application, most probably you can use C#. If you want to use iPhone, iPad, a Mac program, you can use Objective-C. These days, Apple is pushing for Swift. Newer languages like Java are used to create applications like, for example, for Android phones. So different languages, they have different popularity